primary bottleneck in digital real estate is not traffic or inventory, it is the data input layer. Marketplaces depend entirely on a daily flood of raw photographs uploaded by users, data that is inherently subjective, inconsistent, and entirely unstructured. Standard real estate platforms treat this input passively. They function as simple media repositories, accepting whatever files a seller provides and displaying them verbatim, regardless of the lighting, composition, or clarity of the image. Operating as a passive repository damages marketplace liquidity. When property features are hidden in dark, cluttered photos, algorithmic sorting fails. Assets sit mispriced on the market, buyer friction increases, and overall platform trust erodes. Correcting this inefficiency cannot be achieved by tweaking a search algorithm. The intervention must happen upstream. It requires turning the initial moment of upload from a passive file transfer into an active, deterministic data extraction event. This is the architectural thesis behind Kemedar Vision. Instead of treating an image simply as a picture to be hosted, the system treats every individual pixel as queryable real estate data. Contrast the traditional upload pipeline with this intelligent architecture. A user uploads a photo of an empty, raw concrete space, and the system actively parses its geometry, structure, and potential to generate a structured, finalized output. The engine driving this transition relies on large vision language models, specifically leveraging Claude 3.5 Sonnet to bridge the gap between visual input and database architecture. Claude executes a rigid, deterministic data extraction pipeline, translating visual information directly into Kemedar's property photo analysis database schema. Locking raw visual inputs into specific relational database columns enforces platform-wide data consistency. The system identifies and resolves data gaps at the point of ingestion, ensuring high-fidelity information enters the marketplace before a buyer ever sees a listing. The process begins the moment a seller begins uploading. This mobile interface shows the system instantly categorizing uploads, identifying a master bedroom, and rejecting a mismatched balcony shot. In the back-end environment of the Base 44 project architecture, that image is converted into a Base 64 payload and hits the Vision API. The system prompt forces the model to ignore general aesthetics. It acts as an inspector, operating under a strict mandate to hunt for localized indicators and return findings exclusively as valid JSON arrays. We inject specific regional context into the prompt parameters. The model is instructed to scan specifically for MENA market premium indicators: Italian marble, 60 by 60 porcelain tiles, German kitchen installations, and branded bathroom fixtures. Simultaneously, the prompt runs a has issues Boolean check, scanning the exact same pixels for water damage on ceilings, exposed wiring, cracked tiles, and visible clutter. Constraining the vision model to these strict JSON parameters strips away the subjective nature of photography. A visual asset is completely dismantled and reassembled as an objective, highly detailed data row. This real-time parsing breaks a luxury living room into localized data points. The flooring tooltip identifies Italian marble, writing directly into the detected materials array as high-end. Moving to the wall, detecting a water stain trips the has issues array, grading the severity as critical. This specific defect trips a disclosure-required Boolean flag in the database. This creates an immediate operational safeguard, alerting the seller to declare the damage and mitigating legal liability after the sale. Finally, the vision model evaluates the composition, brightness, and cleanliness of the shot, assigning an overall quality score integer from 0 to 100. This structured JSON payload, detailing materials, issues, and image quality, now serves as the quantitative foundation for all subsequent business logic and algorithmic pricing on the platform. With the visual data extracted, the system moves to business logic through algorithmic pricing alignment. This breakdown illustrates the mathematical impact of finishing grades. The system aggregates every JSON file from a property's gallery to calculate an overall finishing grade, ranging from luxury finishes that add a 40% premium down to raw brick that drops value by up to 50%. The core appraisal equation is straightforward. The engine compares the calculated finishing score against the ratio of the listed price to the local market average price per square meter. This gauge shows the algorithmic outcome, weighing visual evidence against math to flag if a property is overpriced, underpriced, or fair. Here, it identifies a discrepancy, advising the seller to adjust their price upwards by 15% because luxury finishings justify a higher premium. Automating this appraisal logic directly from imagery prevents sellers from leaving capital on the table, while simultaneously stopping unjustified overpricing from stalling the market. The architecture moves from simple evaluation to active modification. If the system scans an empty room and sets the "is eligible for staging" Boolean to true, it automatically initiates a virtual staging job workflow. The vision model dynamically writes a specific architectural text prompt, mapping physical dimensions and applying the selected interior design style to populate the space. The generated output is seamlessly integrated into the property gallery. An interactive slider allows buyers to toggle between the raw concrete and fully furnished potential. Style selector checks allow dynamic visual customization, catering aesthetics to buyer preferences and increasing engagement. Shifting from passive hosting to generative intervention removes the barrier of empty room friction for potential buyers. By automating this design labor, Kemedar provides the visual context that correlates with increased inquiry rates in digital listings without the overhead of physical furniture. When we pull back from individual listings, we see how this localized data scales into platform-wide quality control. This dashboard shows the administrative view. The aggregated JSON data populates high-level KPI metrics, tracking the total volume of staged operations, generating a platform-wide quality distribution chart, and flagging critical operational liabilities in real time. Contrast this administrative control with the frictionless buyer interface. They see a curated output, anchored by the Vision Verified badge and feature chips highlighting premium materials. Note the bottom padlock icon. Maintenance issues remain private to the seller, projecting only verified strengths publicly. Structuring visual data this way creates a dual-sided advantage. It provides granular liability management for administrators and immediate, mathematically verified trust for buyers. The pipeline acts as a continuous loop, converting unstructured pixels into rigid data schemas, routing data through appraisal algorithms, and intervening with generative AI. This guidance pushes sellers to create professional listings, building buyer trust, accelerating sales, and feeding back into platform growth. Kemedar Vision proves the most critical phase in a digital real estate marketplace isn't search functionality, it is the point of initial data entry. By architecting a deterministic ingestion pipeline, the platform is an intake clerk, an expert appraiser, and a digital stager, a multi-layered filter for marketplace quality.